Hello. For our sixth example of titration, we're looking at a med that we have looked at earlier in the semester, and that is heparin. So first off, we'll read and then we'll discuss some of the details. The doctor orders a heparin infusion for your 80-year-old, 173-pound, 5'8" male patient at 1,000 units per hour. The solution contains 25,000 units of heparin in a 250 milliliter, 0.225% normal saline bag. So in reading this, the first thing I noticed is that the heparin is not ordered according to a protocol, and it is not ordered based on weight. So the order that I have in this problem is the 1,000 units per hour, and that does not have a per kilogram. And so I don't need to worry about converting the pounds to kilograms. I don't need to use the pounds at all. Second thing I noticed is that this 25,000 units in the 250 mLs, that is the strength. That is what would be in my IV bag. So the first thing I'm asked is to find the milliliters per hour for the order. So I'm going to start with 1,000 units over hours. And I need to get to milliliters per hour. Well, I already have hours, so this part's done. Check that off. I need to get to milliliters. Looking at my ordered amount, that means I'm going to need to cancel units. So units will go on the bottom. And I'm going to use the units that are in the bag to do that. So 25,000. And up here, 250 mLs. And that gives me mLs. So literally that is my one and only conversion. And that's why we did heparin earlier, because the heparin problems, although they sometimes have weight in and are more involved, also can just be one step at a time. So I will take 1,000 times 250 and divide it by 25,000. And I come up with 10 milliliters per hour. 1 hour later, the doctor adjusts the IV to 12 milliliters per hour. So I see that that's an increase. And I am asked, what is the dose that the patient is receiving? So from the first problem, I am going to resort to my proportion strategy of dose over rate. In the first part of this problem, we had a dose of 1,000, and that was units per hour, and we had a rate of 10. So just going back and labeling these so I can really easily see them for when I set up these problems and know what labels are what. This order is a dose, and this first answer is a rate. So those are the two that I am pairing together. In the second problem, then, the piece that I'm given is the 12 milliliters per hour. So that is a rate, so I'll put 12 on the bottom, and I have my X up here. Now, you may see a really nice relationship here, which would make this super easy for us. So if I look at this 10, and then I look at the 1,000, going from the top to the bottom, I see that this is times 100. And so the 12, if I do the same thing on the other side, times 100, I'm thinking that this answer, my X, should equal 1,200 or 1,200 units per hour. But I'm also going to do my math. So over here, I'll do my math. So we have 1,000 over 10 equals X over 12. Cross multiply, 10X equals 1, 2 with 3 zeros. Divide by 10 on both sides. And X equals 1, 2 with 2 zeros, which is exactly what we thought the answer would be up here, the 1,200 units per hour. So this problem can be very easy because I've noticed this relationship. And so here I have 11, and that's like the 12. So if I multiply that by 100, I should have my units, which would be 1,100 units per hour. And then similarly here, I know the dose, which is the top number. So to get to the bottom number, I can divide by 100. And that would be an 11.5 milliliters per hour. Similarly here, this is a dose. So to get to that rate, it looks like I will divide by 100. That's the relationship I noticed, 12.5 milliliters per hour. But if you don't notice, you can continue with the strategy of the dose over rate. So for this problem, dose over rate is 1,000 over 10 is x over 11, and solve that out. And this one, dose over rate is 1,000 over 10. And the 1,150 goes on top because that is a dose amount, and we would put the x on the denominator for that one to solve it out. And then similarly, the last one would be the same idea. So dose over rate is 1,000 over 10. And again, the 1,250 would go on top because it is a dose, and x on the bottom. And so that is how we would get the answers. We can use the shortcut with this noticing of the 100 as the factor between them, or we can set up the proportions for them. Here are the answers all spelled out so that you can check your work.